Hi, I'm Phil, and today I'm going to look at upgrading my Bittle robot dog to Bittle X, which is using a more powerful processor. So let's have a look at what it's all about. So this is the board that I just recently purchased, and it's based on a ESP32 computer, and the sensors are an IMU. So the board uh, is used to control the limbs, that is, the four hips and the four knees of a robot dog called Bittle. So it will control the movements, the roll, and the pitch of Bittle. And my upgrade um, looks similar from outside, and this is what Bittle looks like on the desktop. And I'm going to use a development environment called OpenCat framework. It started about 10 years ago with a robot cat and has moved on. And at the top end, you can add a more powerful AI, Raspberry Pi, to control the more advanced movements and decision making of Bittle. But in my project, I'm just interested in coordinating the limbs to make Bittle move. And the board from the front and the rear looks like this. There's the front, and you've got on the right four Grove ports to add additional sensors for Bittle. Cost-wise, it cost me 100. We'll have a look at the order. I purchased this about the 26th of August, and this is the price that I paid for it with a small discount. Applications, this is good for STEM education and as a robot hobby and a pet for seniors. But it's also useful for programmers that want to see an open source and fairly complex environment for developing robots. So some of the features of Bittle, it's able to drive up to 12 pulse width modulation servo motors, and these are used to control the limbs. The IMU, in my version, the inertial measurement unit is going to still be used to detect the orientation and acceleration of Bittle, and it's used for balance. It replaces the older PMU 6050 with a TDK version. There's no IR on my version. I have Grove modules, and these are quite useful for extending the sensors. So we have transmit, I to C, and also we've got GPIO 34, 35, 38, and 39. There's no EEPROM, um, and all the parameters are stored in flash memory. There's plenty of flash memory compared to the Arduino Uno version. Port-wise, we start off with the serial port, and we can also extend that with Bluetooth and Wi-Fi. And later we can support the Raspberry Pi with the sockets dedicated to the Raspberry Pi on the board itself. So we've done a bit of comparison, and what we're interested in doing is looking at the servos, because this is where the muscle and the power of the limbs come from. So it's not using plastic gears. We've got alloy gears, and we've got a higher voltage, and that gives us the oomph or power for our limbs to work with. Okay, so we'll go from hardware and we'll have a look at the software. Software-wise, we can start off with a desktop application, and that allows us to calibrate our limbs, and it also can be used to download the latest firmware to Bittle X. You can move on to the mobile app on the Android phone, and we'll see that on the desktop demonstrations later on. If you wanted to do simple programming, we could start off with CodeCraft, but that is no longer supported, and it doesn't work with the latest firmware of Bittle. And if you wanted to use simple programming techniques, blocky programming, you could use Mine Plus, and that comes from DF Robot. So you just add the extensions for Bittle, and you can do some simple programming. There's also web block coding, and that allows us to demonstrate the use of TCP/IP and HTTP scripts with Bittle. But the real developer's environment is on the Arduino IDE, and you program in C++. But most of the programming's been done for you already. There's a framework and APIs that allow you to do that. But if you do it, you have to be careful of the way you partition. So even though it will prompt you to partition in 16 megabytes, you have to wind that back to 4 megabytes. Otherwise, it won't compile correctly. And what we might do is have a look at the projects I've been working on. So I commissioned the board with many MIDI projects, and the idea was to replace the NyBoard on Bittle and replace an older version called BiBoard version 0 with BiBoard version 1. And I want to demonstrate that various activities. I want to update the software and test all the different apps that are available. I had some problems with the projects, and mainly in the coding. So I never got the firmware to compile, and I had to get some help to do that. So software-wise, we're going to look at the Arduino, and the one that I eventually got working after many attempts is this project here. So the idea was to compile the ESP32 version of OpenCat and test it with the BiBoard version 1. So I had to do some preparation for my Arduino IDE, and we'll go across now and have a look at the Arduino code. So we've opened up the OpenCat ESP32 on our Arduino IDE, and the important thing is to go to the right under Tools, make sure you've got the right board set. So here I've got ESP32 development module. I've got it set up for the right port, and it's important to get all the other parameters. The one which is really critical is the partitioning scheme. So I've got a minimal SPIFFS, and if you don't set that up, it won't compile correctly. And when you look at the code, we've got compile directives for the type of robot. We've got Bittle, and we're using the BiBoard version 1. There are other versions that you can select. And what's interesting is that all the additional hardware, like the voice module, the ultrasonics, the PIR, and the IR gesture and camera, are all supported in runtime for Bittle X. But for Bittle, you have to have compiler directives to switch on one of the units, because under the Arduino IDE for Uno, there's just not enough room for them all. And you can see what it's like at the beginning. We set up the serial port and we initialize the robot. And we're looking at the battery strength, and moving a bit further down, we look at to see if the web server has been enabled, and we're then ready to go into our main loop. So that's the OpenCat software, but it does use quite a lot of additional support. So we might have a look at some of that now. In the next video, we'll go further and have a look at the sounds of Bittle X. So while I couldn't get music or the MP3 player to work, I was able to get Bittle to recognize my voice and the commands for it to change its behavior. And we'll also have a look at some sensors in more detail, the ultrasonic and reflective sensors, and interfacing. We've done serial already and GPIO, but we're going to add a Bluetooth remote using the microbit computer as a remote controller, and the joystick comes from Freaks to control Bittle. We'll also look at cameras, and we'll compare both the Petoi AI vision camera and the original Mu camera on Bittle. So there's the Mu camera. We were able to get that working on microbit, but not on Bittle, and it was able to detect balls and people. But the one that worked quite nicely on Bittle was the Grove AI vision, and that'll be included in the next version, together with a description of how you can add to Bittle using mechanical mounts, and I arrange 3D printing of those with Electro. Okay, so we'll have a look at what the references are. Before we do that, we'll have a look at the critique. The good things was the software. The Android app worked quite well. So did the desktop. Mind Plus, while it worked, it was a little bit limited. And if you want to really do everything, you have to use the firmware, the OpenCatEsp32, and while you can modify that, it's the one that allows better control over Bittle X, and that's integrated with Grove compatible components, the voice command, the microbit, and also the camera. Mechanically, it's robust, and you can print out all of the components for Bittle using a 3D printer, and there are extra modules available and plenty of support. So I was able to email and get good answers from RongZhong. I guess the bad points were the Arduino is actually quite hard. I needed help to get that going. I was a bit uncertain about what IMU was installed, but I've sorted that out later. I haven't got music to work yet, and I haven't got the MP3 player. There are only minor points. The most important one is at least I was able to get eventually the OpenCatEsp32 firmware to compile on the Arduino IDE. Bluetooth, sometimes it was hard to connect, but I've eventually got that going now quite well. Power-wise, it takes a while for the battery to charge, and you have to remember to turn it off if you want to conserve battery power. The head comes off a little bit too easily. Documentation-wise, there's very little on the upgraded board, the BiBoard version 1, and most of the documentation is for version 0. There's a little bit of inconsistent naming, and some of the apps are perhaps they are reliable and they'll work for you. The summary is I would certainly recommend it with perhaps a little bit more than 5 out of 10. I would probably give it, let's see, we go to the critique, summary, recommended. I would probably give that about 8 out of 10, a much higher score than I originally considered. And what works are the software, and what fails, certainly Codecraft no longer works, which is a disappointment if you want to use additional Grove modules. Okay, so you can go across to the Petoi website and have a look at that. So we'll bring it up now. Here's our website, and you've got Petoi. You can see the price of that at the moment. It looks like it's on special. And we've got plenty of support with the user manuals, and the Petoi Doc Center will give you help with communications and software development. And that's all from me, but stay tuned for a desktop demonstration.
Hi, I'm Kumi Taguchi. On this episode of Insight, embracing or resisting digital technology.
I don't think I would be here if I didn't have my Apple Watch.
I was spending a lot of time on my phone and I wasn't necessarily feeling good or enjoying it.
I've solved my own phone addiction.
I personally will not give my children a smartphone before 16, maybe never.
I understand how to be safe and what's right and wrong to put on social media and how it works.
There's always going to be haters, there's going to be haters in life. Doesn't matter if it's on behind a keyboard or to your face.
Instead of a social life, on Friday nights I would get home from work, order a pizza, get high and watch porn.
Phil, what excites you most about technology?
What excites me is the fact that I'm more creative using the technology to make things. It extends my social network, where I can use it to assist me to volunteer in the community, and it makes me into a citizen scientist, where I can use technology to collect information about my environment and use that with others to find out where we're going.
In the 60s, you studied engineering at Sydney University. What was cutting edge back then?
When I was 12 years old, I went to the Science Museum to see the electric brain. It was a machine that played noughts and crosses. So I was a little bit disappointed that that's all it did, because a brain should do more than just play a game. But I was able to get behind the scenes and see how it worked.
How did you go against the machine?
I never won.
Really?
So we would either draw or it would win.
Let's see that early example of artificial intelligence in action.
Engineer D.W. Davis built an automatic noughts and crosses machine that thinks for itself. No more lonely evenings for the 24-year-old inventor. His machine follows move for move with even greater skill than a human player.
Artificial intelligence is a computer system which performs tasks that normally require a human brain. Phil, how far has AI come since then?
Enormous. Back then, it played little games and it had a good way of interacting. So it made us part of the game. AI today is a lot more pervasive. It's entered into all aspects of our lives.
You run a YouTube channel. What content do you share?
I show content about how to make things with technology. So it's both for children looking at STEM education and they want to code and make things, and it's also intergenerational. So I allow seniors and grandparents to share in some of those experiences.
We went to visit you at home to see some of the projects you're working on. Let's have a look.
I spend about half a day in the workshop putting together something which will animate and come alive. The sort of things that I make include smart cars, robots that have arms, and robots that behave like a dog. But I also make musical instruments. I build things where I can play with them after I've made them. My background was in electrical engineering and science. While I'm now 15 years in my retirement and I'm 75, I'm still learning. I've been running my YouTube account now for about 10 years. I have about 700 subscribers.
Recording in progress.
Hi, I'm Phil, and today we're going to continue with motor drive projects. YouTube allows me to share my interests with many people, and I think that's good to make friends and to socialise. A small computer. My son Jason is 34, he's autistic and he's non-verbal. Technology helps Jason in many ways. He's able to manage his time and he's able to communicate with us using the iPad. How are you going? I try to involve Jason with my own projects. For example, I'll share the construction of a robot and give Jason the screwdriver and he will put it together with me. More recently, I've taken an interest in adding a brain and AI to my robot dog. How about this thing? I would like it to learn how to walk. Using the same techniques that we learned when we were children. Do a pee. Rest. Sit.
This is the original Bittle dog, and it's based on the Arduino Uno computer. And what we'll do is expose the control board by removing the top. And in addition to the control board, we have a Bluetooth dongle that allows us to communicate with a mobile phone app, which is over here. So we might turn on the mobile phone app, get it going, and we'll have a look at the software. So here is the software on our Google Pixel mobile phone. And what we'll do is get it to stand. So all I have to do is just press stand, and Bittle will stand. And we'll get it to rest, and we'll get it to sit, stretch, and say hello, hi. So we'll get it to pee, and to hiccup. Then do a push-up. And to cheer. Then to push. We'll get it to stop. And bring it back to a central position. And we'll get it to stand up. It's already standing up. Push left. So we get Bittle to go push right this time. And to stop. And now we'll get Bittle to walk. So we press the walk button, and here we've got Bittle walking. So we're ready to go to the control panel, and we're ready to talk to a new Bittle. So we'll get Bittle to rest, and we might get Bittle to stand, and we'll get Bittle to sit. So it can do all the tricks that it was able to perform before. Now this Bittle's different. We've got a ESP32 board called the BiBoard V1, and I've also added additional sensors. So a Bittle can actually do tricks for us. Bittle, sit. Walk. So we just have to talk to it. And we don't even need the mobile phone. Rest. So we have our Bittle now under voice control.